Hello, everybody. My name is Andriy, and today I will talk about Azure DataFactory, and I'm going also to talk about migration from AKS story and why Kubernetes could not be a good technical fit for a particular business requirements. So who I am? I am a DevOps community lead at NewFire. I'm conference speaker at DevOps Days, meetups, webinars. I'm active member of Microsoft and Stack Overflow communities. I am Microsoft certified as Azure Solution Architect and Azure Administrator. I'm working in IT more than 10 years, and I was involved in a lot of Azure projects. And I can say that today I will tell you one of the stories that is related to Azure Cloud. What do you think? What are the reasons of slow product delivery? Yeah, you are right. There are a lot of them. And architecture choice is only one of them. And today we'll talk about the bad architecture choice and its influence in product delivery. Also today we'll talk about a lot of services, tools, approaches that I mentioned in this slide, and even more. So let's begin. Let's go, and I'll tell you the story. So this begins when I was working in one of the previous companies. And imagine that we had a client, and there is one development team that was developing a software for a particular client. And that was a 3-tier application, nothing special, front-end, back-end database. But there were 4 production environments. Why 4? Because that was a big company, and they had their offices across the world. And we had to create the production environment for each country. And the government of these countries had the restrictions that customer data were not able to be located outside these countries. So that team was developing this 3-tier application. And then the client, after a year of development, or product development, the client came to into our company and said, you know, it's really cool that you were developing this, you were developing the product for us, and we want more. We want to have the data visibility. And this means that we just need the data to be in our Power BI. So this is the requirements, and you see these requirements, and this is looks simple, right? And our company was really happy, and they said, yeah, no problem. So how much time do we have? The client says, you have half a year. We want to get this done in a half a year. Yeah, no problem. That will be done in half a year. And our team was quite busy with the developing the 3-tier application and developing the new features. And our company said, yeah, okay, our second team will do all the work. And you can't imagine that our second team was really happy to develop this application, this software. And as you might guess, that they were so happy that they wanted to try a lot of new features, approaches, tools. And you can see what they did. So they were really happy to try all these modern trends. First, they decided to did this application in Kubernetes, but unfortunately, nobody knew Kubernetes in their team. Then they decided, maybe we'll try Go. Okay, let's try Go. Nobody knows Go, but no problem, it's trend, we'll learn it. Okay, then GraphQL, yeah, good approach for API. Then let's, how we are going to populate the data. Okay, let's use RabbitMQ. Yeah, good choice. And what they did, so let me explain you briefly this architecture. So they created, as you see, the reader microservice that reads the data from the source database, from production database. There were 4 readers. They were reading every 6 hours. Why every 6 hours? Because processing was taking around 4 or 5 hours, and they said that this is their requirements or restrictions. Then processing. The processing service got the data from RabbitMQ, where reader were pushing the data, and processing make the data, took the data from the RabbitMQ and putting them into the Azure database for Postgres. Postgres and Kubernetes. That was database in Kubernetes. Then the client was getting the data through GraphQL API. And client should also connect via VPN to this endpoint and to get this data. So that was really complicated flow. But client was, let's say, happy because it got the data was visualized in Power BI, so that's it. And how was the deployment done? So deployment was done just from local computer, kubectl apply, and that's it. So that was the architecture flow. And as you might notice, that then our company decided to move this project from the second team to our team. Why? Because they decided, this is ready. You just need to maintain this project, and that's it. It won't take a lot of time, and it's easier to maintain one product in one team or 2 products in one team. Okay. Oh yeah, no problem. So it's interesting to maintain 2 products, to develop and maintain 2 products. So after that, we started to try to understand what is the project. So what is the architecture, how it's written, and other things. And first, we were surprised that the deployment is done through local computer, just kubectl apply. No SDLC flow, nothing was set up, and we were disappointed. Then what we discovered, that the database updates or schema changing and the API was written not really in good manner. So for example, let me explain, if the changes, if the order of the columns were changed, the API was not working. And this is, so we got this issue from client that the client is not able to get the data from the database, from the system. And we started investigating. It took around 2 days to understand the Go, to understand that architecture. So developers had such rolling eyes. Why that was developed in Go? Why GraphQL API? So that was really awful, and that was not really easy to understand and to fix, to support this system. That was even worse. So the client started reporting new bugs, and the team started working on fixing those bugs. And we cannot afford to fix the bugs in this reporting system and to start adding the features in the 3-tier application. So we decided to go further, and this point, our journey starts. So what we decided to do? So we were thinking maybe it is easier to convince the client to just or push the client to approve changes, to approve the new architecture. So we were thinking that it shouldn't take a long time to just rewrite the application. It will take less than 6 months. And let's take a look what we can find, what we can suggest the client. And we started our investigation, how we can rebuild efficiently our application. So, but let's pause our video, our story, and take a look on low code. Yeah, low code is the approach where the developers or the companies that are developing their product, that they just creating their flow, their application in UI, in GUI, and it is easy to create this application without low code, without low configuration. And a lot of companies are doing that. So, and you see that the low code platforms are growing, and amount of money companies are spending for low code is also growing. So at this point, let's resume our story and go further. So what architecture was the first one we were considering? This was just simple, just let's take Azure Functions, get the data from 4 databases, merge them in Power BI dataset database. That's it, simple, yeah. But there are a few buts, yeah. Strong customization is a big plus. Low cost is plus, as Azure Functions cost almost nothing. Then, but there are the disadvantages. So the development time could be more than 1 month, because this was our strict deadlines, internal deadlines. So we can offer the client. Long-running processing is not the appropriate fit if we are going to use Azure Functions. Azure function can run only 10 minutes if we use consumption plan. Maintainability. Yeah, it's hard to maintain the code, then the Azure Functions, the monitoring. So also we had a limitation of Azure Function that it has only 1.5 gigs of RAM. So we can use only this amount of RAM in the consumption plan. So that's where the disadvantages. And we decided, let's see what can we do. The next architecture that we're considering is Azure Analysis Services. So it's really simple from the first look solution, and the development time can take let's say a week or so. And really cool thing that near real-time data can be near-time flow can be implemented using this feature, using this analysis service. Why? Because we can add analysis service, then pull data from the database and push data into Power BI, and this in real time. Yeah, cool. But it supports only the single data source. So we had to implement Azure Functions that would merge data, and then the analysis service will get the data from the merged database and put this into the Power BI. So unfortunately. Customization. Yeah, the customization is not easy to implement. And the cost, yeah, analysis services cost more than Azure Functions, definitely, and more than current solution Kubernetes that cost, I think, around $300 or $400 per month. So what's next? We understand that this architecture is not fit. So the next was the architecture with stream analytics. Yeah, also the streaming near real time and Azure function that could get the data from the data sources, put into the event hub, then stream analytics, then Power. Yeah, looks cool. But we first need to transform the data from relational database, from tables, into the JSONs, because stream analytics supports the JSON format, CSV format, and it's very limited to the supported formats. And we'll need to make the data transformation, which takes time. So the development time is also could be higher, and definitely cost. So this solution costs more than $300-400 per month. So this is not our solution. Let's move next. And that was our, let's say, final solution, final idea, is to make the data factory the primary ETL service for this. As this is the common approach for ETL, is just our approach: get the data from the production database, transform this data, then extract, transform, and load. ETL, right? That was optimal cost for us, because the data refresh intervals we decided to decrease for an hour, and it supports multiple databases, multiple data sources. Yeah, cool. Minimum development time, as a lot of things we have to develop in UI. Then there are disadvantages. Yeah, so deployment strategies are not so clear and hard to implement in the current SDLC flow, but we'll talk further about this. Data optimization. This is not the best, let's say, feature of Azure Data Factory. And we had to create our own data optimization approaches and data optimization software that will do it better. I will tell about this further also. As you see, this was our optimal solution, to use Azure Data Factory. So, but we decided to use the Azure Data Factory. Then we had to present this to the client. And when we are starting preparation for this presentation, we understood that there are a couple of issues or a couple of challenges that we'll face with. But the client said that, yeah, guys, 1 month is okay. And he said that it will cost less than $300 or $400 per month. Yeah, and 1 month of development, 1 month for investigation, 1 month, 1 week for investigation, 2 weeks for development, and 1 week for testing. And it would be, the usability would be better for this solution. We said, yeah, okay, we start. So first, we should think about how to optimize cost in Azure Data Factory, because you know, if we load all the data from this database every time, that was waste of money and waste of time, waste of resources. So the data refresh interval should be 60 minutes, and it's also, we're talking about the costs. If refresh intervals would be less, let's say 5 minutes, 10 minutes, we would pay more. Then data should be merged from multiple Azure SQL databases, and it could make a performance to the production databases. So then we had to remove the VPN, which client was used to connect to this reporting system. And also the CI/CD, which we talk about later. These were the challenges, and then I'll tell you how we were able to resolve all these problems and issues. So Here's the architecture. And as you see, so we first added the replica databases into the current production databases to avoid performance, to avoid load on the production databases, additional load to the production databases. So we started pulling the data from the replica databases. So Azure DataFactory did it really good. Then we wrote our own Azure function to make the transformation. Why we need it? Because we decided to get only the deltas, so the changes from last committed transaction, get the latest changes, the delta changes from these databases, from the tables, get them, transform them, and pull these into the SQL database, the destination database, and then push this data into the Power BI. So that was the concept. But let's see in more details, especially for Azure DataFactory. We created two pipelines. Yeah, the first one is multiple databases, and the second is single databases. The multiple database pipeline was only needed to start the iteration transformation data for all these 4 production databases. That's it. As you see in this slide, there are 3 activities: get function up key, the key from Azure Key Vault is the key of our Azure function. All the secrets were stored in Azure Key Vault. Then set current timestamp needed to check the current database changes in destination DB and in the source DB, and then run this pipeline, so execute database ETL. Let's see more deeply in the single DB pipeline because it's more interesting. Yeah, so let's first look on the left and see the activity get current version and get last version. These are the activities that gets the current version in the destination database, the current version of the committed transaction, and get the last version and compare these versions. And then we could understand that the last transaction in source database is higher than the current transaction in the destination database. We compare them, and then we will need to get these changes. So we put get current version and get last version to the Azure function. We invoke Azure function, and Azure function then process or then gets the script from the source database for the last changes. Only we are interested only in the tables that had changes. That's it. So this function, what it does, it's just get this script and to generate the script and to make an output to the to the next activity. Next activity is get table with changes. So we need to understand what tables are changed with generated script. So we have script generated for tables, and then we'll need to put all of this into the next activity to get the tables to be copied from the source database to the destination temporary database. destination database in temporary tables. So we are copying only the deltas, tables with deltas, from source to destination. And then when we copied all the data from source to destination, we need to merge this data. And why merge this data in the destination database, you could ask, because some of the data could be deleted, some of the data could be changed in the tables, and we need the script that could merge all this data together and without any issues and without any problems, without any conflicts. So that is the purpose. So that is the flow that we are using in our Azure DataFactory pipeline. It could be, for some of you, pretty straightforward, so for some of you, no, but this works great for us. But what about the CI/CD? You could ask me, right? How to do that? And there are a couple approaches. I will tell you a bit more. First approach is, you can see in the slide, this is approach from Microsoft. So we have Azure DataFactory, and all the development is done in this Azure DataFactory UI. Then, when the developer created his pipelines, make a commit, and Azure DataFactory automatically make a commit into the main branch, into the master branch. And after that, we have our code in master branch. But the code means the pipelines in code, the JSONs that had the configuration for pipelines. Then we have the separate folder that calls ADF publish branch, and this branch is used for RM templates. So all the data factory are stored in RM templates, and the pipelines are stored in JSON files. So what is the approach? The approach is to deploy all the data factory from RM template. This is, I cannot say this optimal solution, but that works. And what I can say that it's really easy to implement, but not easy to understand from the first time, because it's not really much in the SDLC trunk-based development or Git flow. So then when we have these changes from the Azure Data Factory into GitHub, then from the GitHub, we can deploy RM templates. In Azure DevOps, for example, it can be the PowerShell script that stops the trigger of the database, then deploy RM template, and then start the trigger. And the deployment can be done in development, test, and prod. And with RM templates, as you might know, we can specify the parameters for each environment. So this is the approach that is recommended by Microsoft. So there is another approach called JSON approach, and this is not officially supported by Microsoft. But what I can say, so the development phase is the same, pretty same. So developers are making changes directly in Azure Data Factory UI. The Azure Data Factory UI making the commits into the main branch, but we are making the deployments from main branch, not from ADF publish branch, but from the main branch. Also in Azure DevOps, it could be implemented when we are making the changes into the main branch, our pipelines, and pipelines are deployed into the environments. So, for example, we are creating the package in Azure DevOps, then making the release, and then executing the PowerShell script, or we can use the add-ons from Azure Marketplace to achieve our deployment goals. So, and after that, we're deploying in dev, test, or production environments. So, and that is the approach that could be. But maybe some of you could ask me, but how about Terraform? Could you please tell us, is it possible to deploy using the Terraform and infrastructure as a code? I can say yes, but no. Yes, but complicated. Because yeah, infrastructure as a code is really cool concept. And Terraform has modules for Azure DataFactory. Yeah, definitely. You can find the Azure DataFactory module, Azure Pipelines module. You can create this module. You can deploy Azure DataFactory. But there are some challenges with this. Why? Because you have to integrate the Terraform into the approach of that Microsoft recommends. For example, you will need to still define your pipelines as JSONs. If you see in the module, in the pipeline Terraform module, you'll see that the configuration is simply JSON. So you have to make changes into in Azure DataFactory UI, commit this into the branch, into main branch, and from the main branch, get these JSONs and put into the Terraform code. So it's there are challenges to do that. No? That's why that Terraform is not pretty used in the Azure DataFactory to cover all the infrastructure as a code concept. So all the changes, it's a bit difficult to implement this approach. So what could be the scenarios for the Azure Datafactory? In our case, that was the simple ETL scenario. So just get the data from the Azure Datafactory, it's from the Azure SQL, process the data inside the Azure Datafactory with Azure Function, and push the data into the destination DB and in Power BI. Yeah, simple approach and standard ETL scenario. So, but also the use cases for Azure Datafactory are pretty the same: ETL, extract, transform, and load. So it's the process at which the data are copied from the source database, or databases, data sources, and pulling into the system that could represent the data. Also, there are different use cases for loading the data in the warehouse without visualizing the data, getting the data from different data sources and loading it into Azure Synapse for reporting, or some modeling and visualizing and pulling the data into visualizing tools for data analysis. These are all the approaches for Azure Datafactory. And I can say that it's not really a solution for streaming, but it's a really good solution for ETL. But what are the trade-offs? So as you see, there are no good tool that could do everything and without trade-offs. Yeah, you have to pay for everything. And what we saw when we are trying to implement the data factory, that we had the Azure Data Factory has limited sources and sinks. So that's why we had to implement our own Azure function. And maybe in your case, you will have all the things, all the features in Azure Data Factory, and you will achieve your requirements or your goals with built-in features of Azure Data Factory. But for us, it didn't work. So the pipelines are written in their own language, and you have to first learn this language and go with with this, so you have to spend some time. Yeah, and the development of data factory flow in UI could be confusing for the developers from first point, but then it's easy to do that in the UI. This is the approach of low code. Yeah, so we're talking about the high price when using to closer to real-time processing. Yeah, that's true. And data factory CI/CD processes may differ from common software development CI/CD process. Yeah, if you're having trunk-based development or Git flow, the SDLC flow of Azure Data Factory will be different, and you should work with this and understand that it's a separate case. It's a separate case. So let's make a summary. So first, the summary of the project. We successfully finished this migration within a month, and the client was really happy. He said, "Whoa, I didn't know that it could be implemented within a month, and the data load could be 1 hour instead of 6 hours. Yeah, you did amazing work and it cost less. Whoa, that was really tremendous." And our team was really happy to implement these things, to solve the business case of the client in an appropriate way. So if you are going to implement Azure Data Factory for your purposes, for your business needs, you first think about what is your code branching strategy. Because if you have trunk-based development, Git flow, GitHub flow, or any other flows, the Azure Data Factory has its own flow. So you have to understand this. How many environments do you want? And what environment will be used for development purposes? If development purposes, we just develop and not deploy into this, or also deploying then these changes to test. And what are the flow of deployment? Yeah, what tool we are going to use for CI/CD of the data factory? What deployment method to use? RM templates, PowerShell scripts, or some add-ons from Azure DevOps Marketplace? These are all the questions you need to answer before implementing the Azure Data Factory. And what artifacts are you going to use? Are you going to use RM templates or just pipelines in JSON files? And this has direct influence into the model you are going to use within Azure Data Factory. And I can say that for us, it was a really cool, optimal solution, the Azure Data Factory. Yeah, these are the trade-offs, the CI/CD trade-off, the trade-off of the development, but it's low code. So you're working with a tool that has different approach. And so about the low code, there are a lot of companies and startups that just on its way to building their own application. And they need the faster way to make the development of their application. And low code could help them to do that. You saw that I showed in one of the slides that the amount of low code solutions are growing. And that is really great thing that you can create your application, your flow, your business, your pipeline of business really fast without additional code. And this is the cool thing that helps the business to make the deployment of their architecture, the development of their software, and low code is a good example of our future. So I used these materials to prepare for my presentation, for my talk. And if you want to share your problems, ideas, if you want to talk about this presentation, this topic more, you can find me on LinkedIn, on Facebook, and we can talk about this more. So thank you for your attention, and it was really interesting for me to present this topic and to share my knowledge with you. So I hope it was really helpful and interesting for you. And I wish you a good day today, and thank you very much. Goodbye.